It's okay. Here is page 3 of the study guide. Page 3 of the study guide. Write the domain and range of each function. Go ahead and we're just gonna cross out tangent here. We're not gonna do tangent on this test for domain and range. We're gonna stick with sine and cosine. So looking at sine theta, the domain of sine of our normal trig functions is all real numbers. So all real numbers. I guess that'd be theta, not x, but theta is in all real numbers. Same with cosine. We can use all real numbers from negative infinity to positive infinity. They all work. They all work for the regular trig functions. Our range is all the possible y values. So our lowest y value is -1, and our highest value is +1. And the same is for cosine as well. It just fluctuates from -1 to +1 and back. -1 to +1 back. But if we take the inverse, we go the opposite direction, we have to play around with the original domain to make sure it still stays a function. So by taking the inverse, our range becomes our domain. For both of these. And then we have to restrict the domain of the original function for our range here with the inverse function. So inverse sine is restricted to quadrants -1 and +1, or 4 and 1. So we want to go from negative pi over 2 all the way to pi over 2. And those are inclusive, so closed on both sides. So negative pi over 2 all the way to positive pi over 2. And then the inverse, the range of inverse cosine, we can just use quadrants 1 and quadrants 2. So it starts at 0 and goes all the way to pi. Quadrants 1 to quadrants 2. We do need to keep in mind the range for inverse tangents. That's going to be almost the same as sine. -1 and +1, so negative pi over 2 to pi over 2, but these are going to be open intervals. You cannot include the endpoints. The endpoints are undefined. So looking here, find the exact value of each trig function. So I see square root of 3. So square root of 3 tells me that it has to be something over 3. It's going to be some version of pi over 3. Now, tangent is square root of 3 at pi over 3. So if I have negative square root of 3, that just means I need negative pi over 3. I need the negative version of quadrant 1. So that's our final answer, actually. Negative pi over 3. Inverse cosine of negative root 3 over 2. Some programs don't put the parentheses here. I like the parentheses. They're not needed, but I think it looks pretty. So we just need to find out when is cosine negative root 3 over 2. So we go here, look at all our x values in quadrants 1 and 2 until we get to negative root 3 over 2. That's right here at 5 pi over 6. Sine of negative 1/2. Well, here again, we have to use quadrants -1 and +1. So we can look at just where is sine 1/2. That's going to be here at pi over 6. And because it's a negative, we just put the negative down here. And we're done. Cosine of square root of 2 over 2, positive. So cosine is square root of 2 over 2 right here at pi over 4. And negative root 2 over 2, well, that's going to be pi over 4 again, but because there's this negative here with sine, we got to bring that negative out, and we get negative pi over 4. A negative inverse cosine of negative root 3 over 2. So we can't do any fancy tricks with the negative here. So we just look, where is it? Negative square root of 3 over 2. Well, we've already checked it right here. It's the same one as this one. So we know that this is going to be 5 pi over 6. But I have to bring this extra negative right here down. That's been added to the equation. So we bring that down, and we get negative 5 pi over 6. Next up is inverse tangent. So we want to do inside the parentheses first. Inverse tangent of pi over 3. So that's going to be right here. Not pi over 3, square root of 3. Inverse tangent of square root of 3 is pi over 3. So we simplify this to be sine of pi over 3. And then the sine of pi over 3, look back at our circle, so we got pi over 3, sine is the y value, square root of 3 over 2. Cosine of inverse tangent of negative 1. So tangent is negative 1 right down here at negative pi over 4. Not 7 pi over 4. Do not put 7 pi over 4. So we want cosine of negative pi over 4. And we get that because we need, so it's tangent of 1, and you just bring the negative outside. So you can do the same. It behaves the same as sine. So cosine of negative pi over 4. So negative pi over 4 is right here. Cosine value is square root of 2 over 2. And then finally we have inverse tangent of cosine of pi. So we start with cosine of pi. Pi is right here. Cosine is negative 1. Inverse tangent of negative 1, as we've already talked about over here, is negative pi over 4. There we go. Okay, that concludes that page. I'm going to stop recording here, and I will see y'all in the next video for page 4, I believe it is.